Hi, this video we're going to look at another example of 2D equilibrium. So the problem setting a ship, unloading operation, a 3,500-pound automobile is supported by a cable. And so that's a cable. A rope is tied to the cable. And pull to center the automobile over its intended position. What is the tension in the rope? Okay. So how do we solve this problem? First step is we're going to look at FBD. And this is I don't intend to draw the automobile because all I need to care is this point A, because all the force is gonna acting at A. Okay, so we have the weight of the automobile. It's just gonna go straight downward. I don't care how this rope is connected, right? If I'm care about only point A, that's all the forces. That's the weight of the automobile. That's gonna be weight equal to 3,500 pounds. And then we're going to have a tension right here. And I'm going to call TB because it's point B here. That's the tension in the rope TB. And the TB is 2 degrees here. Obviously, my angle is way more than 2 degrees. Okay, and then we also have another tension in the rope. And this, of course, we're going to call TC, right? And this one is 30 degrees from horizontal line. So those are the three forces that's acting on this point A right here. Weight and two tensions. And those three forces have to balance each other. They are at equilibrium. So that's our FBD. And we also notice there are two unknowns, and we're gonna have come up with those two equations: forces at x and forces at y equal to 0. So that's what we are going to do. Now let's take a look. This time we're not gonna draw the table. We're gonna throw away our training wheel, directly going to forces at x. Okay, so there are three forces. We're going to look at x component of each of the three. Let's start with TC, okay? TC is right here. If I were trying to just figure out what's the x component and y component on this FBD, and I know this is my TCx, this is my TCy component. And how about x component? What's that equal to? It's adjacent to 30 degrees, so it's going to be cosine. So that's going to be TC cosine 30 degrees. And it's pulling to the right, so it's positive. Then the next force we're going to look at is weight. The weight is going downward. There's no x component. So that would be plus 0. Then the third force we're going to looking at is going to be your TB. So again, we're going to decompose TB. TB, I'm going to use green color. That's going to be our y component. That's going to be our x component. So that's our TBx. This is our TBy. And as right now, we are looking at x component. So with respect to this 2 degree, this is opposite. So we're going to use sine 2 degree. And we're going to use TB times sine 2 degree. And this is to the left, so that's going to be negative. So plus negative. And that's all the three forces add up together that equal to 0. Now we're going to do for the y component. Forces at y. First, we're going to looking at TCy. What's that value equal to? Because this is 30 degrees. TCy is going to be opposite, so that's using sine 30. And besides, if you use cosine 30 in the x, this y have to be sine, right? And so TC times that And do you realize this is going downward? So that's going to be negative. So that's y component of the force TC. Now let's look at the weight. That's our second force. What's the y component of the force, of the weight? You realize it's all going down to the y component, and it's all 3,500, and it's going downward, so it's going to be negative. Okay, so next, the last force is our TB, and our y component is this one right here, right? And with respect to 2 degree, that is adjacent, so we're going to use cosine. So it's TB times cosine 2 degree. And it's going upward, so it's positive. So positive, and that's going to give us equal to 0 because it's at equilibrium. You have two equations, you have two unknowns. Those unknowns are TB and TC. So the rest is just in solving that equations. Again, here we're going to, I'm going to take a quick picture and I'm going to go back to our Wolfram alpha just to demonstrate solving these equations. All right, so the first term is TC. And we learned Wolfram does not take multivariable. So we're just going to use C. That's going to be our variable. C times cosine 30 degree. Then plus 0, get rid of that, minus sine 2 degree times B. That equals 0. Separated by comma, second equation, it's going to be negative sine 30. So hopefully you're doing this with me at the same time. Feel free to pause. C minus 3,500, then plus cosine 2 degree, then times B, that equals 0. Then enter. Let's look at the form first. So they do cosine 30 times C. That's what we intended, equal to 0. So far, everything looks good to me, this equation. And they have figured out the equation doesn't look like what I wanted because C has B and so that's not what I exactly wanted. Let's see. And so what I realized is the mistake I made is this is not a 0, this is O. So I'm going to change to 0 and hopefully that will fix the problem. Troubleshooting, right? Okay, yep, that does it. So this is going to be your answer for this problem to solve TB and TC. That is right here. So I'm going to go back to my note. And then we said, okay, we solved it. And the answer for TB is going to be 3574.2. And our TC is going to be 144.03. And that's going to be pound. Then we solve this problem. Okay. All right. See you next time.